Hello there, and welcome. I'm so glad you found your way here. Maybe you're winding down after a long day, or maybe you're the kind of soul who sleeps best with a little mystery on your mind, something vast, ancient, and quietly astonishing. Whatever the reason, you're in the right place. Let your body soften, let your breath ease, let your thoughts drift not away, but deeper. Because tonight, we're not counting sheep, we're traveling back over 300 million years to a world where all the land on Earth was one single, immense continent called Pangea. Before the oceans separated us, before mountain ranges rose to divide, before Earth wore the face we know it wore another. We'll explore that world tonight. Its slow dance of drifting plates, its deep-time creatures, its fractured echoes still found in rocks, rivers, and rainforests. These aren't just facts. They're fossils of wonder. This isn't about remembering everything. It's about feeling it, the way the earth remembers, slowly, deeply, softly. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Imagine standing at the center of a world where all the continents you've ever known are pressed together, stitched side by side into a single, sprawling landmass. No Atlantic Ocean, no Pacific, no division between East and West. Just one unbroken continent, encircled by an endless sea. This was Pangea, Earth's last great supercontinent. Not just a piece of history buried under stone, but a vast, breathing chapter in the story of our planet. It didn't simply exist. It ruled the Earth for over 100 million years. A world without borders, without familiar coasts, without the geography we think of as permanent. Everything you know about the shape of the world was, for a very long time, untrue. Pangea began not with a bang, but with a slow, grinding pull. It formed in deep time, when the pieces of older continents were drawn together again and again by tectonic forces working beneath the surface. Plates moved quietly over the mantle, like ice flows on a dark sea, colliding, merging, folding into mountains. The continents that had once wandered apart began their slow reunion. It was not a sudden gathering. It was a long embrace, formed over hundreds of millions of years as the Earth's crust responded to invisible heat and pressure far below. The continents closed the oceans between them. They pulled shut the vast Rhyic Ocean and the pale, shallow seas that separated them until there was nothing but land meeting land. South America curled up beside Africa, North America pressed against Europe. Antarctica drifted in from below like a pale, forgotten puzzle piece, aligning itself in the south. Even India, not yet the subcontinent we know, was tucked quietly along the eastern edge of what would one day be Asia. The fit was uncanny. The seams still show, like old scars. To live in the age of Pangea would be to walk a landscape more massive than we can easily imagine. You could travel from what is now eastern Russia to the western edge of Brazil without ever crossing a sea. A single walkable Earth. The climate was different then, shaped by its shape. With no scattered continents to stir up weather or distribute moisture, the interior of Pangea was dry, vast, and harsh. Deserts stretched endlessly across what is now the heart of Africa and North America. Storms gathered over the Superocean Panthalassa, circling the rim of land in huge, seasonal sweeps. Monsoons would batter the coasts and then die out before ever reaching the center. The land in the middle of Pangea may have gone years without a drop of rain, but even that dryness bore life. Strange forests, massive insects, amphibians longer than grown humans. Reptiles prowled river valleys that now lie buried beneath entire nations. The creatures of Pangea evolved together, spread across continents that were not yet separate. Fossils from South America match those in Africa. Identical fern imprints lie in rocks from Antarctica and Australia. These are echoes, remnants of a time when Earth's life moved freely across the land without ever touching water. The edges of Pangea were more active, alive with tectonic tension. As the plates collided to build the supercontinent, they buckled upward, forming mountains that still stand today. The Appalachian Mountains, ancient and rounded, were once part of a chain that stretched across the Atlantic and into the mountains of Morocco. The Ural Mountains rose between what is now Europe and Asia. These were not just landforms. They were the physical memory of collision, of impact slowed down over millions of years until it became structure. It's strange to think of a world with only one edge, one vast coastline stretching unbroken around the entire planet. And yet that's what Panthalassa was, a single global ocean, deeper and more mysterious than anything we know today. We've never seen its full floor. It was destroyed as new oceans formed, recycled by the slow churning of the mantle. But its waves touched every side of Pangea. Its tides shaped the first complex coral reefs. Its currents may have helped mix life across the globe, even as the land remained still. Looking at a modern globe, it's easy to believe in permanence, that the continents have always been where they are, shaped only by rivers and time. But they haven't. The Earth is restless. Its surface is more like cracked glass floating on a sea of fire, constantly moving, drifting, folding, and pulling apart. Pangea was only one chapter in that long process. Before it, other supercontinents came and went. After it, the land shattered again. And yet, Pangea holds a special place, not just for its size, but because it's the one we've mapped best, the one we can trace with a kind of eerie clarity. We know how the pieces fit. We can run simulations that show the plates pulling together, curling around each other like continents remembering who they used to be. And we can watch them drift apart again, in slow motion, toward the familiar world we now inhabit. Its name means all Earth, and that's exactly what it was. A moment when the Earth gathered itself inward, when the land touched itself again. And maybe there's something comforting in that the continents we live on were once connected, that the division we see today, the borders, the coasts, the distances, are temporary things. Beneath the names and flags and languages, the land remembers being one. If you could stand on Pangea and look up at the stars, they would be in different positions, drifting slowly as the Earth's rotation changed. The moon would still be there, slightly closer, pulling on tides that circled the world in a single ring. Volcanoes would burn along rift zones, rivers would wind across thousands of miles. And beneath it all, the plates would be preparing to move again. Because even Pangea wasn't forever. In time, the heat beneath the crust would rise, faults would stretch, valleys would split open, and the supercontinent would fracture not with violence, but with the quiet inevitability of motion too large to stop. Oceans would return, the land would part ways, and the world would become many again. But for a time, Earth was one, and though that time has passed, its imprint is still everywhere. Beneath our feet, within the rocks, in the matching coastlines of places we think of as far apart. We walk through its echoes every day, rarely noticing. The world we know is just the aftermath of a unity we forgot. But Earth has not forgotten. The plates are still moving, the continents are still drifting, and one day, far in the future, they may come together again. Time, for the Earth, does not move as it does for us. It doesn't rush, doesn't sprint, doesn't mark itself with minutes or days or the flickering hands of a clock. For the Earth, time is patient. It unfolds in layers, in pressure, in the slow grind of stone against stone. It lives in silence, in eras, in the invisible breath of things so ancient they have forgotten the meaning of haste. And when we speak of Pangea, this colossal continent that rose and fell long before the first tree you've ever seen, before birds, before even flowers, we are speaking in the language of deep time, a language we were not built to understand, but which cradles us all the same. 300 million years. It's a number too large to feel, too long to hold in your mind without it slipping away. Say it out loud, and it still sounds like fiction, and yet it is real. It is written in every mountain range, every fossil bed, every layer of rock pressed beneath your feet. The age of Pangea is carved into the bones of the world, like rings inside a tree, except the tree is made of continents, and its rings are epochs. To grasp deep time is not to count years, but to feel their weight. Imagine a single second, a moment. Now imagine 1 million of them. Now multiply that by 300. That's Pangea's age. And yet, to the Earth, it was only a season, a moment of gathering before another long, slow unraveling. Compared to the lifespan of our planet, 4.6 billion years, Pangea is just one fold in an impossibly vast origami, and we, humans, modern and blinking in electric light, are barely a spark on the edge of tan. Its last page. Geologic time is measured in eras, periods, and epochs, names like the Carboniferous, the Permian, the Triassic. These aren't just chapters, they're entire volumes, each one spanning tens of millions of years. In the age of Pangea, the world moved through 2 major periods and brushed against a third. Forests rose and fell, oceans changed shape, species emerged, thrived, and vanished, all while the land remained joined. What we consider ancient, the rise of human civilization, the first cities, even the last ice age, is so recent in comparison, it barely registers. If Earth's history were a single day, humans would arrive in the final second before midnight. And yet here we are, trying to look back, trying to reach across chasms of time, not with our bodies, but with thought. We measure it in rocks, in the radioactive decay of isotopes, in the slow shifting of magnetic fields recorded in lava flows. We read the Earth's memory like a blind person reading Braille, by touch, by feel, by signs so faint they would be invisible to anyone not looking with incredible care. The rocks remember. They do not lie, but they speak slowly. Every layer of sediment is a page in the Earth's journal, a record of what the wind was like, what the ocean carried, what died, and what lived. Some layers are chaotic ash from volcanic eruptions, evidence of impact events, sudden die-offs marked by a lack of fossils. Others are peaceful, slow deposits of silt and clay that suggest calm, shallow seas, rich with life. And between them all, there are gaps, not because time stopped, but because sometimes the Earth erases its own writing. This concept, this dizzying, beautiful stretch of time, is what makes Pangea both real and surreal. It forces us to understand that nothing is fixed, that continents drift, not in metaphor but in fact, that mountains rise and fall like breaths, that what feels eternal, the ground, the coastlines, even the shape of the river, Earth itself, is nothing more than a temporary arrangement. In another 300 million years, the planet will look nothing like it does today. And we, whatever we are then, or if we are anything at all, will be another whisper in the layers. But there's something strangely comforting in that. Not insignificance, but placement. We are small, yes, brief, but we are part of something long and large and quietly unfolding. We walk on continents that have been many things. We drink water that once moved through ancient seas. The atoms in our bones have been here before us, and they will be here after. They remember the magma and the ocean and the fern forests of ancient swamps. When you look at a stone, know that you're looking into time. Not time like a memory, but time as it exists without us. A volcanic rock may be 150 million years old, And that number is not an exaggeration. It's a truth. A fossilized fern pressed into shale is a relic from a world where no birds had yet taken flight and where the air smelled thick with decay and damp heat. Every cliffside is a cathedral of time, and every canyon a wound through the earth's past. To learn about Pangea is to learn the rhythm of slow things, to begin hearing the tempo of a world that does not hurry. The supercontinent did not arrive overnight. It was the result of collisions that spanned generations of life. It drifted into place like a raft on a molten sea, and when it broke apart, it didn't shatter. It peeled slowly. The land sighed, stretched, and opened. New oceans seeped in. The continents began their long journeys to the positions we know today. And that journey is still happening. Africa and North America are still drifting apart. The Himalayas are still rising as India pushes into Asia. Earth has not stopped breathing. We are simply living in a shallow moment of its long inhale. When you try to hold 300 million years in your mind, it slips through your fingers. That's okay. You weren't meant to contain it. You were meant to witness it, to sense its shape. And tonight, as your thoughts slow, you can imagine it not as a line of numbers, but as a pulse, steady, ancient, alive. The breath of deep time still exhaling beneath your feet, beneath the stillness of the ground, beneath the forests and cities and oceans. The earth moves. Not in earthquakes or eruptions, not in the dramatic bursts we notice, but in a slower, deeper way. It moves like breath, like thought, like sleep. And what we walk on, what we build on, what we call the continents, is not anchored. It floats. It drifts. It slides on a layer of rock so hot and pressurized it behaves not like stone, but like something softer, slower, more fluid. The continents are not fixed platforms. They are rafts of ancient rock, drifting on the planet's mantle like leaves on a pond of fire. This is plate tectonics, the quiet engine of Earth's transformation. It's not a theory anymore. It's the foundation of modern geology. And it begins with the lithosphere, the rigid outer layer of Earth, cracked into a mosaic of massive plates. Some of these plates carry oceans, some carry continents, some carry both. And all of them are in motion. We don't feel it. It's too slow for our senses. But the continents are shifting beneath us, a few centimeters each year, a pace not unlike the speed at which your fingernails grow. It seems trivial, almost laughable, until you let time in, until you realize that a continent moving 3 centimeters a year will travel 300 kilometers in 10 million years, and the Earth has had time, lots of it. The plates ride on the asthenosphere, a hotter, more ductile part of the upper mantle. This is where the movement begins, not as a push from above, but as a cycle from within. Mantle convection is the process. Deep inside the Earth, heat from the core rises toward the surface. When it reaches the base of the lithosphere, it spreads sideways, pulling and stretching the plates above it. Cooler material sinks, creating a cycle: hot rock rising, cooler rock falling, in a rhythm that lasts millions of years. It is slow, vast, and invisible, but it is constant, and it is the reason the continents move at all. Sometimes, the plates pull away from each other. This happens at divergent boundaries, where new crust is born from molten rock rising between them. The Mid-Atlantic Ridge is one such place, a vast underwater mountain range where the Eurasian plate and the North American plate are drifting apart. Iceland sits right on this seam, a place where the Earth is literally opening. Lava seeps up through the rift, cools, and becomes new crust. The ocean floor is growing, silently, mile by mile, year by year. Other times, the plates collide. When two continental plates meet, they crumple. The crust thickens and rises into mountain ranges. This is how the Himalayas formed, as India pressed into Asia, shoving rock upward in slow, unstoppable waves. The mountains are still growing. The collision is still happening. Earthquakes echo along the edges, like the creaks and groans of an old ship straining in the wind. When an oceanic plate meets a continental one, the oceanic crust is usually denser and it sinks beneath the continent in a process called subduction. This is not a gentle descent. The sinking plate melts as it falls into the mantle, generating magma, pressure, and often volcanic arcs. The Andes are born from this process. So is the Pacific Ring of Fire. Where plates meet, the world shudders and remakes itself. And yet, most of the time, we notice none of it. The drift is too slow. The rise of a mountain takes longer than the span of human history. The spreading of a seafloor is measured in whispers. But the evidence is everywhere. We see it in matching fossils found on opposite sides of oceans, in the jagged puzzle of Africa's west coast and South America's east coast, where they once fit together like pieces torn apart, in satellite data that watches the plates move centimeter by centimeter, in the volcanoes, in the rifts, in the mountain chains that curve like frozen waves. The continents are always moving. They always have been, and they always will. Pangea was not the beginning. It was only the latest gathering, the most recent moment when all the plates converged in a single, unified landmass. Before it, there were others, Rodinia, Nuna, Columbia, each one rising from the slow dance of drifting plates, each one breaking apart again. The Earth is not building towards something. It is breathing, in and out, together and apart. This movement shapes more than landscapes. It shapes life. When continents join, species meet, ecosystems merge, and evolutionary paths shift. When they break apart, isolation begins. Populations split, evolution diverges, new species emerge, adapted to different continents, different climates, different challenges. The drift of continents is also the drift of life. Without it, we would not be here. There's a strange poetry in this motion, that the ground beneath us so solid, so trustworthy, is actually gliding atop a sea of hot rock, that what we call land is not anchored, but adrift, that our maps are only temporary snapshots in a movie too long for any one frame to show its meaning. The Earth remakes itself, over and over, and it does so without our permission or awareness. The continents move not because they choose to, but because they must, because the planet beneath us is alive, and it does not rest. And so, as you lie there now, the ground beneath you is moving. Just a little, just enough. Africa is sliding northward. The Pacific is shrinking. The Atlantic is widening. Somewhere, deep below, the mantle breathes heat upward, and the plates respond, slowly, endlessly, soft as sleep. For a long time, the Earth's surface was seen as fixed. Mountains stood where they always had, oceans divided, continents that had always been apart, and the idea of land drifting across the globe was as impossible as watching the stars rearrange themselves. But the Earth has always left clues, silent ones, patterns etched in stone, whispers trapped in fossilized leaves, scars in mountain ranges that stretch across oceans. These weren't meant to be found. They simply existed, waiting quietly for someone to notice, and slowly we did. The first clues came in pieces that didn't seem to belong. Fossils of the same ancient plants and animals began turning up on separate continents, divided by thousands of miles of ocean. In South America, paleontologists uncovered the remains of Mesosaurus, a small freshwater reptile that should never have crossed a saltwater sea. And yet, matching fossils appeared in Africa so perfectly preserved, so specific, that coincidence was no longer possible. Then came Glossopteris, a fern-like plant with broad leaves, its fossils scattered across India, Australia, Antarctica, and South America. These plants couldn't have floated across oceans. They grew in place, which meant those places were once the same. Geologists began to notice the rocks. Identical layers of sedimentary stone, stacked in the same order, appeared on opposite sides of the Atlantic. It was as if someone had torn a book in half and thrown the pieces apart. Basalt flows in Brazil matched those in Western Africa, down to their magnetic signatures. When lava cools, iron particles inside align with Earth's magnetic field like tiny compasses. Over time, the field shifts and flips, and those alignments become locked in stone. Rocks become records, and when those records matched across continents, the evidence grew harder to ignore. Mountain ranges, too, told their story. The Appalachians, which wind through the eastern United States, share their age and structure with the Caledonian Mountains of Scotland and Scandinavia. Not just similar, they are fragments of the same range, broken apart when Pangea split. The rocks match not only in type, but in stress patterns, in the way they were folded and formed under pressure. You can trace the pressure scars, like fingerprints, and they line up, across oceans that weren't always there. Even Antarctica joined in. Under its ice, scientists discovered coal beds, fossilized forests, the remains of lush, warm ecosystems. Coal does not form in frozen deserts. It forms from dense plant matter in humid, swampy conditions, and yet, here it was, hidden beneath glaciers, telling us that Antarctica was once part of a larger, greener world. A world joined together, basking near the equator, before drifting into the deep freeze of the south. For centuries, these hints piled up, and still, the idea of moving continents felt too strange, too big. The evidence was there, but belief was slow to follow. It took a German meteorologist, Alfred Wegener, to stitch the pieces together. In 1912, he proposed that the continents had once been a single landmass, Pangea, and had drifted apart over time. He wasn't a geologist. He didn't have the math or the mechanics to explain how. But he saw the clues, and he trusted the patterns. He looked at the coastlines the way South America fits into Africa like a puzzle, and he listened to the fossils, the rocks, the ranges. He believed the Earth had moved. The scientific community resisted. It was a radical idea, and Wegener lacked the machinery of proof. He died before the theory gained traction. But the clues waited. They were patient, the way only stone can be. And decades later, technology caught up. With sonar mapping, scientists discovered the mid-ocean ridges, underwater mountain chains that marked places where the Earth was pulling apart. With paleomagnetism, they read the history of the seafloor. With satellite data, they tracked the actual drift of continents, confirming what had once been intuition. The hidden evidence became visible. It's strange to think how many truths lie beneath our feet, invisible until the right question is asked. The Earth doesn't announce its history. It tucks it into layers of shale and bands of granite, into fossilized spores and symmetrical fault lines. It hides it in the alignment of iron, the tilt of strata, the direction a glacier once dragged across the land. And yet, it always tells the truth, if we know how to listen. We live on a planet with memory. It remembers the time before maps, before names, when the world was one, and through the clues it offers quiet, scattered, waiting we can begin to remember too. We don't need to see Pangea to know it was real. Its shape still lingers, not on the surface, but in the structure of what was left behind. The continents drifted, but they didn't forget each other. Their edges still echo the break. Their cores still hum with the memory of contact. And perhaps the most astonishing part is not that the evidence was hidden, but that it waited so long, perfectly preserved, for us to notice, for us to find the pieces, for us to begin, at last, to understand the shape of a world that once was whole. Before there were 7 continents, before there were named seas or shorelines to trace with your finger across a map, there was Pangea, and around it, in every direction, stretched a single, boundless ocean, Panthalassa, a name that sounds like a whisper from a dream, or a place invented in myth, but it was real. A superocean so vast it wrapped the entire globe, encircling the supercontinent like a crown of water, like breath around the Earth's sleeping face. Panthalassa didn't have borders. There were no islands to interrupt its sweep. no familiar coastlines to divide one nation from another. It was uninterrupted, unbroken, and unimaginable in scale, covering more than 2/3 of the planet's surface. You could have sailed for thousands of miles in any direction without seeing land. And in that enormous silence, life unfolded in strange, unknowable ways. The ocean floor of Panthalassa has long since been recycled back into the Earth's mantle, pulled down by the slow churn of plate tectonics. Almost no trace of it remains, not in the way we think of physical evidence. No great fossil beds, no ancient trenches to visit. It exists now as memory in the rocks that formed at its edges, in the magnetic trails locked in the crust of the Pacific, in the ghost patterns of long-erased seafloor. It is a place we can no longer touch, but we can imagine it. Picture a world where you stand on the edge of Pangea, gazing out not at another continent, but at endless blue. There is no Europe beyond the Atlantic, no Americas to break the line of sight, only water. The wind would carry the smell of salt and deep currents. The sun would rise and fall without striking distant land. Storms would build without warning and circle the globe without interference. And beneath the waves, in that alien dark, life teemed. Panthalassa was not empty. It was alive. In its depths swam the ancestors of creatures we know and many we do not. Ammonites spiraled through the water, their shells tight like fists of time. Ichthyosaurs cut through the currents like silent missiles, their bodies built for speed and pressure. Trilobites, though fading, still crept across the seafloor, clinging to the final chapters of their era. Plankton bloomed in staggering numbers, turning sunlight into energy and seeding the food chains that would shape everything to come. Entire ecosystems, vast and unknowable, moved in the silence beneath the waves. And yet, for all its size, Panthalassa was also a mirror. The patterns of heat, the pull of currents, the spin of the earth, these forces created gyres and eddies, upwellings and dead zones. Just like today's oceans, it had warm shallows and cold trenches. And just like today, it responded to changes above. When the climate shifted, the ocean breathed in heat or released it. When Pangea drifted slightly, the currents changed course. Nothing was still. Nothing was truly separate. Scientists believe that Panthalassa played a role in shaping the climate of the entire planet. Its currents moved heat from the equator to the poles, regulating temperature in ways we're only beginning to understand. Its vastness meant that atmospheric gases were absorbed and stored in its waters, changing the chemistry of both sea and sky. It acted as a buffer, a stabilizer, and sometimes a trigger. When life in the ocean changed, the world changed with it. And then there were the extinctions. Panthalassa bore witness to some of the most dramatic die-offs in Earth's history. The most devastating, the Permian-Triassic extinction, sometimes called the Great Dying, wiped out over 90% of marine species. The cause is still debated. Some blame volcanic activity, others point to methane release or shifts in ocean oxygen levels. But what remains clear is that Panthalassa became a graveyard. Vast stretches of ocean turned hypoxic, suffocating the life within. For a time, silence ruled the sea again. But extinction is never the end of the story. In time, life returned. It always does. Slowly, patiently, in strange new shapes and forgotten forms. Fish with new jaws, reptiles with fins. Coral rebuilt its cities from the rubble. Panthalassa, though wounded, kept moving. It swallowed the dead and cradled the living, its currents washing over bones and eggs and floating spores. As Pangea began to break apart, Panthalassa began to fracture. The newborn continents tore into the ocean, creating new margins, birthing new seas. What would become the Pacific, the Atlantic, the Indian Ocean. These bodies of water that feel so permanent to us are, in truth, fragments, shards of a greater whole. The Pacific Ocean, the largest of them all, still holds Panthalassa's echo. It still remembers the rhythms of a world where water wrapped everything. And maybe we do too. There's a reason we look out over the ocean and feel something ancient stir in us. A reason we stand at the edge and fall quiet, as though listening for a voice that's just out of reach. The sea is older than the mountains. It remembers when the land was one, when all life rose and fell in its arms. Panthalassa may be gone, but it left us the feeling of enormity, the hum of continuity, the hush of an ocean too big to hold, too old to forget. The next time you hear the waves, know that they are part of that lineage. They are pieces of a lullaby the earth has been singing for hundreds of millions of years. A song without beginning or end, carried across a sea that once had no shore. Long before Pangea reached its full form, before it became the great cradle of life's ambition and the stage for Earth's boldest tectonic ballet, it was already many stories deep. It was not born whole, not summoned all at once from beneath the sea, but rather built over time from older fragments. Two immense landmasses, Gondwana and Laurasia, drifting toward one another across a restless planet, slowly knitting together into the supercontinent we now try to imagine. But even before they met, each held histories written in stone, climates, and bone, two halves of a puzzle older than memory. Gondwana was the elder. It came together in the deep hush of the Precambrian, nearly 600 million years ago, when life was still soft-bodied and the continents were only beginning to dance in familiar shapes. It included what we now call South America, Africa, Antarctica, India, and Australia. A world tilted toward the southern hemisphere, wrapped in tropical warmth and ringed by shallow seas. Gondwana was massive and ancient, and its rocks carry the marks of snowball Earths, of great ice ages that swept across its breadth before the world thawed into green. Its forests were wide and lush. It gave rise to creatures who would one day walk on land. And when you dig into the red earth of Australia, or the ancient highlands of Ethiopia, when you find trilobite fossils in the cliffs of Argentina, or the same folded rock patterns on the coast of Western Australia and East Africa, you're touching the scattered bones of Gondwana. It was a world unto itself, complete but incomplete, waiting for the other half. Laurasia was younger, but no less vast. It formed later, in the northern hemisphere, when several smaller cratons like Laurentia, Baltica, and Siberia began to merge. What emerged from that convergence was the ancestor of what we now call North America, Europe, and much of Asia. Laurasia carried the long, ancient shields of Canada. The plains of Eurasia and mountain belts formed when it collided with others, again and again. Its life forms were different, its climate cooler, its journey rougher. But it was destined to meet Gondwana, and together they would become something larger than either could be alone. The meeting of these two giants was not sudden. It was a slow compression, a continental choreography that took tens of millions of years. As the oceans between them narrowed, as the crust crumpled and folded and mountains rose in protest, the Tethys Sea was pushed aside. Volcanic arcs lit the edges, the margins collided, and where once there were separate worlds, there was now one, Pangea, a landmass so vast that it altered wind and water and life itself. But the memory of division was never fully erased. Even in unity, Gondwana and Laurasia retained their identities, split roughly into southern and northern realms, divided by the scars of their collision. The fossils don't lie. The creatures of Gondwana often looked different from those of Laurasia. Distinct evolutionary stories unfolded on either side of the joined land, like two melodies playing in counterpoint. Where Laurasia harbored early mammals with sharp teeth and nimble limbs, Gondwana gave rise to enormous reptiles, strange beaked herbivores, and lush ferns that spanned entire continents. And when Pangea finally fractured, when its seams gave way and its crust pulled apart in slow, aching stretches, it did not crack randomly. It broke along the old lines. The ancient sutures between Gondwana and Laurasia reopened, like healed wounds remembering how they once bled. Gondwana split into its pieces, scattering southward into today's continents. Laurasia tore into what would become Europe, Asia, and the Americas. Even in the break, the earth remembered the way it once was. The story of Gondwana and Laurasia is not just about merging, it's about legacy, about how even the deepest unions hold the outlines of what came before. We see those outlines now in the geology beneath our feet. We see them in the matching mountain chains, the fossil trails that make no sense without a map that rewinds time. We see them in the deep structural differences between the continents, differences born not from the recent past, but from a time so distant it's hard to hold in the mind. A time when the earth wore different skin. There's something haunting about these two lost worlds, and how they came together only to drift apart again. Something familiar, as though the planet itself was practicing the rhythm of relationships approach, collision, transformation, and release, as though even continents must learn how to carry history in their bones. Tonight, the land you sleep on may have once been part of Gondwana or Laurasia. It may have ridden the leading edge of a collision or rested quietly in the interior of the supercontinent, far from the crashing waves of Panthalassa. But wherever you are, the earth beneath you remembers. It remembers the warmth of tropical Gondwana, the storms that lashed Laurasia's coastlines. It remembers the push and pull that drew them together, and the slow heartbreak that pulled them apart. And as you rest now, the plates still drift, still hum with ancient motion. The names have changed, the shapes redrawn, but the story continues. The past is not gone. It's just buried deep beneath our cities, our forests, our dreams, waiting, still warm, still whispering. When continents collide, they do not slip past each other quietly. They grind, they rise, they fold in slow, silent violence. And when the pressure becomes too much for the crust to bear, the earth lifts its skin into peaks. Mountains are not born in a single moment. They are not sudden. They are the accumulated outcome of deep resistance, of opposing forces pressing into each other for millions of years until the land has no choice but to crumple upward. In this way, Pangea left its mark not just in the way the continents once fit, but in the ridges and ranges it carved across the face of the planet. The Appalachians were among the first. Older than the Atlantic Ocean that now separates them from their kin, they once stood as tall as the Himalayas. Their formation began long before Pangea reached its full shape, when ancestral fragments of North America, Africa, and Europe drifted toward one another. As they closed the distance, their edges caught, then crushed, rocks folded and fractured, heat from below melted some, and new stone formed as mountains rose along the eastern edge of Laurasia. Today, the Appalachians are softened, weathered by time and rain and wind, but beneath their gentle green ridges lie the compressed remnants of an ancient upheaval, a slow collision that echoed across continents. The Urals, far to the east, are another scar from Pangea's assembly. They stretch quietly across Russia now, separating Europe from Asia, but they were forged in fire and force when Laurasia closed the gap with a smaller continental fragment drifting from the south. The crust didn't fracture cleanly, it rippled. Rocks pushed over each other, old layers climbing atop new ones, twisting like cloth pressed in a fist. Deep within the Urals are rocks from the ocean floor, pieces of the ancient sea floor caught in dot. The crush and lifted high. They shouldn't be there. But the earth, in its patient violence, is full of such contradictions. These mountains, these ridges and folds, are not random. They are records. They remember. Their orientation, their mineral makeup, even the magnetic direction of particles in their stone, all point to the moment of creation, when two plates met and refused to give way. They do not just sit silently in the background. They shape wind and weather. They guide rivers and define coastlines. And even in their old age, their bones still shape the world around them. If you look closely, The mountains tell you where the earth once moved. You can trace the line of the Appalachians across the ocean to the Scottish Highlands, to the spine of Scandinavia, where the same collision left mirrored scars. Together, they formed a single chain, now torn apart by time and drift. The mountain ranges are not just remnants, they are echoes. They speak of a world joined together, where the rocks we stand on today were once neighbors, part of the same rising crust. It's easy to think of mountains as eternal, unchanging monuments, but they are born, they erode, and eventually they die. The process is just too slow for us to witness. Every jagged peak will one day be worn down to rolling hills. Every range will eventually vanish beneath the sediment it once fed. But before they fade, they pass on their stories, fossils of sea creatures found high in the Himalayas, layers of metamorphic rock twisted like ribbon in the Alps, traces of ancient forests buried under miles of pressure. In every case, the mountains carry pieces of something older, something formed at the edge of impossible pressure. When Pangea began to break apart, the fractures didn't erase the mountains. Instead, they left the ranges behind, scattered across the drifting plates like breadcrumbs. And so today, when you walk through the Appalachians or the Urals, you're not just walking through forest or along a trail. You're walking through the evidence of collision, across stone forged in contact zones, across the stitched seams of a world that once pressed together into one shape. The strange part is that these ancient collisions still affect how we live. They influence soil types and rainfall, where cities form, where rivers run. They control what can grow where, how species spread. Even now, long after the drama has ended, the stage still determines the play. These mountains may be quiet now, but they still guide the script of life, and the earth isn't done. New mountains are forming. The Himalayas are still rising as India presses into Asia, carrying the memory of Gondwana in its roots. Every year, they grow taller by fractions of inches, still young, still reaching. And in some distant future, new supercontinents will form, new collisions will occur, and the crust will rise again in new places, different mountains, same story. So if you ever find yourself among the trees of an old range, or standing at the foot of a mountain worn soft by time, know that you are standing where continents once collided, where stone once bent, where the earth took a breath and lifted itself skyward in slow defiance. These places are not just beautiful, they are ancient sentences written in the language of pressure and time, and they are still speaking. When the world was whole, life moved differently. It didn't have to navigate vast oceans or adapt to sharply divided climates. There were no isolated continents, no scattered islands forming their own distinct branches of evolution. Instead, there was one vast land, Pangea, stretching from pole to pole, ringed by a single ocean, and blanketed in the silence of deep time. And on that endless terrain, life spread with a kind of freedom it would never know again. In this unified world, creatures could walk from one end of the earth to the other without ever crossing water. Forests sprawled in dense bands across the interior, filling low basins and coastal deltas with ferns, conifers, and towering horsetails. The air was thick and warm, rich with oxygen during certain epochs, and the rhythms of life pulsed wide and uninterrupted. Species didn't evolve in isolation. They shared the same soil, breathed the same air, bathed in the same prehistoric sun. Giant insects thrived in that atmosphere, dragonflies with wingspans as wide as eagles, millipedes longer than a grown man. In the warm, swampy lowlands, they crawled and glided through ancient forests, their size made possible by the abundance of oxygen and the absence of predators large enough to challenge them. These insects weren't monsters. They were experiments, shaped by conditions we can barely imagine now. Their bodies hummed with the slow, ancient logic of evolution, perfectly suited to the unified world around them. Amphibians dominated the wetlands, some sleek and serpentine, others broad-backed and armored. They were the quiet rulers of rivers and shallow lakes, breathing both air and water, slipping between worlds like living metaphors. Their skins were sensitive to shifts in moisture and temperature, making them early witnesses to change. And change was coming, because the most astonishing creatures of this world were only beginning to rise. Reptiles, small at first, began to stretch their limbs longer, strengthen their jaws, and lay eggs that could survive away from water. These were the early architects of a lineage that would soon cast giants across the land. Dinosaurs were not born in an instant. They emerged gradually, step by step, as evolution tested new forms and favored the bold. In the unified ecosystem of Pangea, they had space to expand vast plains to thunder across, coastlines to nest beside, open skies to look up into. Some grew immense, their necks stretching like cranes into the treetops. Others ran swiftly, balanced on powerful legs, their tails counterweights to perfect motion. And deep, some were strange crested, plated, horned, feathered. Evolution had room to play, to try, to fail, and to flourish. These creatures were not just survivors. They were expressions of deep-time creativity, built not for one environment but for an entire world. What's often forgotten is how alike life was across the continents back then. Because the land was one, ecosystems weren't confined to one region. Fossils of the same species have been found in what is now South America and Africa, in Antarctica and India, in Europe and Australia. This sameness, this biological continuity, is one of the great fingerprints of Pangea. It tells us that the Earth once operated like a single stage, and all life, whether crawling, flying, swimming, or walking, was part of one vast, interwoven play. But even in this connected world, there were gradients. The interior of Pangea was dry, swept by powerful winds and cut off from the moisture of the sea. Deserts sprawled in rain shadows and basins, while coastal regions soaked in more temperate climates. Some creatures adapted to the arid center, sturdy, heat-tolerant, water-wise. Others clung to the lush edges, where the forests were thick and the rivers ran long. Diversity still bloomed, but it bloomed across a continuous canvas, not in fragmented patches. And with that continuity came risk. When the environment changed, when the atmosphere shifted, or the climate grew unstable, life had fewer places to hide. A unified world meant that a single catastrophe could ripple far and fast. Volcanic activity, shifting sea levels, fluctuations in carbon and oxygen, all of these could sweep across the land, affecting ecosystems thousands of miles apart. Life was vast, but it was vulnerable. Still, it endured, it adapted. And for millions of years, the unified world teemed with creatures unlike anything we see today. A chorus of calls in humid forests, the thunder of footsteps across muddy floodplains, wings slicing through air unbroken by mountain ranges or oceans, eyes blinking under alien stars. Every creature part of a single global experiment. Eventually, of course, the land began to break. Pangea fractured slowly, like a dream fading at the edges. Continents drifted apart, oceans opened between them, and with each new gap, evolution splintered, diverged, reinvented itself. The descendants of those unified creatures changed, diverged, and gave rise to the astonishing biodiversity we know today. But deep in the bones of the earth, in the fossil beds and stone layers and the genes of every living thing, the memory of that unified world remains. A time when all life walked together, when the earth was one body, breathing in unison, and life, bold, strange, and immense, rose to meet it. In the heart of Pangea, far from the edges where ocean met land in the whisper of waves, the earth was dry. It was a dryness that defied comparison. Not like the deserts we know today with scattered oases and shifting sands, but something more immense, more absolute. A desolation so vast that it seemed to stretch forever in every direction. An ocean of dust and rock under a sky that could not decide whether to bake or break open in fury. These were the interior deserts of the supercontinent, places so far from water that rain became a stranger, and wind shaped the land more than rivers ever could. The size of Pangea made its climate a paradox. Along the coasts, where Panthalassa lapped against stone, storms brewed in endless spirals, powered by the sun, and the slow churn of water warmed at the equator and cooled at the poles. These storms moved like breath, slow, rhythmic, powerful, circling the edge of the continent in belts of wind and rain. But their reach was limited. The deeper you went inland, the more their touch faded, until at last, all that remained was heat, silence, and dust. Here, the air was dry enough to pull moisture from stone. The days were blisteringly hot, and the nights dropped cold and sharp, as if the stars themselves were drawing the warmth away. The soil cracked and split, the surface hardened into crusts that resisted life. And yet, life tried. Some plants learned to store water deep in their roots. Some reptiles found shade in burrows, emerging only when the sun dipped low. Survival here was not guaranteed. It was negotiated daily. The vast deserts were shaped not only by absence, but by movement. Winds raced unbroken across thousands of miles, carving dunes that shifted slowly over time. Dust storms could rise without warning, towering high into the atmosphere and darkening the sky for days. Sand would pile against cliffs and bury entire stretches of lowland, and sometimes, when the monsoon belts shifted or the tilt of the earth drew clouds slightly inland, rain would fall all at once briefly, violently slicing into the dry earth, carving channels that vanished again into dryness. These moments of storm were not gentle. Thunder echoed over empty plains, lightning struck with nowhere to hide, and the rain, though life-giving, came so quickly that the ground could not hold it. Flash floods surged through canyons, cutting paths that would become the bones of future rivers. Then, just as suddenly, the sky would clear, the water would retreat, and silence would return. The plants that had sprouted would dry to dust. The heat would resume. Pangea's immense size also meant that climates were exaggerated. The lack of nearby oceans meant less humidity, less regulation, more extremes. Summers were hotter, winters colder. In some regions, ice would creep into corners, while, just a few latitudes away, heat cracked the earth. The supercontinent created its own weather patterns, its own feedback loops. The usual rules did not apply. Even along the coasts, where the sea kept the air moist and storms were more regular, unpredictability still ruled. Tropical cyclones spun off the warm Panthalassan waters, some enormous enough to strip forests, others gentle enough to bring renewal. The shoreline was a place of transition, a narrow band between wet and dry, storm and stillness. Life flourished here in bands, adapted to flux and change, never expecting permanence. And yet, within all this, life found rhythm. It always does. Creatures evolved to time their lives with the rains, emerging only when the air was thick with moisture. Plants grew tough skins, deep roots, and strange strategies. Some trees dropped their leaves entirely to survive long dry spells. Others grew broad, waxy leaves to trap every droplet that passed. The land, though unforgiving, was not lifeless. It simply required patience. We think of deserts as empty, but emptiness is a kind of illusion. The interior of Pangea held the memory of ancient rivers, of seas that once divided its parts before they merged. Fossils lie buried there, curled in positions of sleep or heat-stilled death, remnants of creatures that braved the heat. They speak of adaptation, of creatures that once walked across this vastness when it was forested, when it was swamp, when it was alive in other ways. Because the deserts too had seasons. They were not static. They changed, slowly, with time and tilt and orbit. What is now stone was once green. What is now barren once sang. And the storms that circled Pangea, relentless, colossal, did not vanish. They carried salt and scent from the ocean, carved cliffs, cooled shores, and sometimes wandered inward far enough to remind the land of water. In their fury, they told the story of a world still breathing, still moving, still changing. They were the boundary between stability and chaos, keeping the deserts contained, whispering to the land that change was always possible, even if it came slowly. Now, when you see great deserts on modern maps, Sahara, Gobi, Outback, you are seeing echoes. These are not just regions of aridity, they are geological memories. They remember what it means to be cut off from water, to endure long silences. Their stones carry the heat of that ancient dryness. Their dust still lifts in winds that once moved across Pangea. And somewhere deep beneath the surface, the earth remembers a time when land stretched on, when storms circled without end, and when the breath of the world moved slowly over sand. Before the continents split and drifted apart, before the Atlantic carved itself between coasts that had once been neighbors, there was a forest so vast, so deep, that it whispered through two future worlds at once. It grew thick and unbroken across the southern sweep of Pangea, a green breath stretching from the heart of what would become South America to the cradle of what is now Central Africa. These were the deepest roots of the rainforests, the ancestral lungs of Earth, woven together long before the continents knew they would part ways. This forest was ancient even in its own time. It thrived in the warm, wet band that wrapped around the equator, nurtured by steady rains and the constancy of sunlight. The air was heavy with moisture and filled with sound. Life surged here in layered tiers, ferns sprawling along the forest floor, towering trees above them, and an endless canopy that filtered the light into shifting green gold. Vines wove like veins through trunks older than any civilization. Fungi bloomed and vanished. Insects traced forgotten hieroglyphs through the leaves. It was not a single forest, not exactly, but it was a single ecosystem, unified not just by the soil or the weather, but by continuity. No oceans between, no barriers to keep the roots from stretching or the seeds from drifting. Creatures could roam from one side of this green expanse to the other without encountering a sea. Plants could evolve in one part and take root in another. The genes of frogs and ferns, dragonflies and flowering trees flowed freely across the landscape. The forest was whole. This is why, even now, separated by an entire ocean, the Amazon and the Congo share a secret symmetry. Beneath the differences of species, of scent, of sound, there are echoes, similar families of trees, related species of birds, parallel layers of ecological structure. You can feel it if you walk beneath their canopies, if you listen long enough. Something in the rhythm of rain, the hum of life, the layered patience of green upon green. It tells you this story is older than any map. Fossils confirm what the forests remember. Pollen grains, preserved in sediment for hundreds of millions of years, show unmistakable links between the two continents. Ancient spores match across oceans. Imprints of leaves, perfectly mirrored, lie in stone beds that now rest on opposite sides of the world. Even the soils so rich and dark in places, so ancient and thin in others, reveal histories written not by humans, but by forests older than language. And the forest shaped more than the air and soil. It shaped life itself. Early mammals crept through undergrowth here. Primitive birds took their first flights through these branches. Strange amphibians croaked in the heat of night, and insects evolved wings that could dart between shadows. The stability of the climate, the abundance of water, the density of life, it created a crucible where complexity could bloom. The rainforest wasn't just a backdrop, it was a forge. When Pangea began to crack, it wasn't sudden. The forest didn't fall in a day, but slowly, imperceptibly, Rifts opened, land shifted, new coastlines formed, and the roots that once stretched unbroken began to pull apart. Rain still fell, and green still grew, but the unity was gone. The ancient forest, once whole, was now divided. One half drifted west, the other east, and the Atlantic, like a slow breath of separation, filled the space between. The rainforests didn't die. They adapted. They held fast to their fragments of Eden, rebuilding their symphonies on opposite shores. But something subtle lingered, a kinship, a quiet knowing, as though the trees still remembered the time when their roots were tangled together. And over millions of years, each rainforest wrote its own story. The Amazon became a tangle of rivers and shifting sediments, home to sloths and jaguars and plants that bloom once in a generation. The Congo became a cathedral of shadows, dense and mysterious, alive with gorillas and okapis and orchids that drink mist from the air. They are different now, shaped by time, by isolation, by evolution, but the memory remains. It is buried in their DNA, in the way certain plants still produce identical toxins or flowers of nearly indistinguishable shape. It is carved in the migration patterns of birds that still cross the ocean, unaware that their route was once a single forest path. It is even in us, in the medicines we derive from bark and root, from leaves that remember more than we do. And so the deepest roots of rainforests are not just in the ground, they are in the past, in a time before separation, in a forest that stretched across a single continent, breathing in unison, dreaming green dreams under the same sun. Even now, when the wind rustles the canopy in the Amazon, and a matching breeze stirs the leaves of the Congo, perhaps something ancient stirs with it, something old enough to remember, something that does not care about borders or oceans, because once, long ago, they did not exist. It did not begin with a bang, or a quake, or any sound that the creatures of that time would have noticed. It began in silence, deep silence far beneath the crust, where molten currents stirred with the patience of aeons. Down in the mantle, heat shifted like breath, building slowly, pushing gently, then more firmly, until the very bones of the supercontinent began to feel the strain. Pangea, vast and still, and seemingly eternal, had held itself together for millions of years. But nothing on Earth stays still forever. Not mountains, not oceans, not even the land beneath your feet. The first signs were not violent. They were subtle, valleys where none had been, uplifts in the rock that made rivers change their course. The slow appearance of cracks so wide, so deep, and so long that they looked like the earth was pulling itself apart. These rift valleys were not wounds, they were beginnings, places where the crust stretched thin and heat from below rose to meet it. Lava flowed not in fountains, but in steady, glowing sheets, cooling into new land even as it pulled the old land apart. In these early moments of separation, the continent didn't shatter its side. It shifted, just slightly, but enough. Enough to begin what would become one of the most dramatic transformations in planetary history. The central scar of this great fracture can still be traced today. It began somewhere near what is now the region of modern-day Africa, where the crust began to dome and split, forming the seeds of the Atlantic Ocean. Back then, there was no sea, only a great rift, a valley stretching thousands of kilometers, bordered by high ridges and laced with rivers that fell into newly forming basins. Life above ground went on, for a while, as if nothing had changed. Forests still hummed with insects. Dinosaurs still walked their steady paths. But below the surface, the earth was beginning to write a new story, slowly stretching its skin, creating new fault lines, new edges, new futures. The process wasn't quick. It would take millions of years, but that's how continents move, not with urgency, but with resolve. As the rift widened, water began to find its way in. Rain fell into the deep valleys and stayed there. Lakes formed, then inland seas. Over time, the weight of water and the pull of gravity helped the fracture deepen. Eventually, the ocean would arrive not as a flood, but as an invitation. Panthalassa, the endless ocean surrounding Pangea, seeped in, carving its way through what had once been a unified landmass. A narrow channel became a widening sea. What had been connected began to drift. The forces at work were immense, but they moved like breath in sleep, slow, rhythmic, irresistible. Plates of the Earth's crust floated on the mantle like rafts on a restless sea, pulled by convection currents and the unceasing heat from the planet's core. Where they met, pressure built. Where they pulled away, valleys formed. It's easy to forget that continents are not fixed. They are travelers, gliding on a surface that seems solid, but is always in motion. Pangea was never meant to last. It was always part of a larger cycle, the gathering and the scattering of land. In the beginning, the separation was gentle, but as the landmasses moved farther apart, the pace quickened. Africa began to drift away from South America. The rift between them, once a valley, became a sea. India, once nestled tightly into the southern arc of the continent, began its lonely voyage northward. Laurasia and Gondwana, the two great halves of Pangea, began their own distinct journeys. The supercontinent's unity unraveled like a tapestry pulled at the edges, strand by strand. Even as it fractured, it did not forget. Mountain ranges bore the scars of ancient collisions. Fossils lay buried in mirrored layers on opposite sides of widening oceans. The coastlines of South America and Africa still fit together like puzzle pieces, their edges shaped by an ancient embrace. The story of the fracture is not only about separation, it's about memory. The Earth remembers, in its rocks, in its ridges, in the quiet symmetry of two distant shores that were once one. And through it all, life adapted. New coastlines brought new climates. Ocean currents changed, rain patterns shifted, creatures migrated or vanished. New ecosystems emerged in the spaces where land had pulled apart. And always, the Earth moved on, unhurried, unstoppable, turning itself, slowly inside out. We look now at the continents and call them names: Asia, Africa, Europe, the Americas. But these are just chapters in a story that is still unfolding. The fracture that began with Pangea is not over. The plates are still moving. The continents are still drifting. Somewhere, deep beneath our feet, the Earth continues its long exhale, reshaping the surface in silence. And if you close your eyes and imagine that ancient land green, immense, unbroken, you might feel the faintest pull of its parting, still echoing in the bones of the world. There are moments in Earth's history when the planet speaks not in whispers, but in roars, when the land doesn't just shift or crack, but erupts furiously, endlessly, as though the mantle itself had grown restless and sought release. One of those moments came during the breaking of Pangea, when something deep beneath the crust opened wide and molten rock poured out in volumes so immense it drowned valleys, smothered forests, and rewrote the sky itself. This was the Central Atlantic Magmatic Province, or CAMP, though names came long after. At the time, it was simply fury. Imagine a wound in the earth that didn't scab over but continued to bleed fire for thousands of years. Not a single volcano, or even a range, but a province, a region, stretching across what would become 4 continents. It spanned what is now eastern North America, western Africa, parts of South America, and Europe. Lava surged up through vast cracks, not in sudden explosions, but in slow, suffocating floods. It did not blast outward. It rose steadily, inexorably, covering everything in its path. In places, the molten rock flowed for weeks without pause. In others, it cooled and then cracked open again, as more surged from the mantle's hidden chambers. Layer after layer of basalt spread like spilled ink across the landscape, burying ecosystems whole, seeping into riverbeds, filling lowlands, and hardening into stone. Entire regions were flattened beneath black sheets of cooling fire. Forests were carbonized where they stood, rivers boiled, creatures fled, but there was nowhere to run for long. The eruptions weren't local, they were planetary. But the most devastating effects came not from the ground, but from the air. The lava carried with it gases, carbon dioxide, sulfur dioxide, methane released in quantities that the atmosphere had never seen before. With each new fissure, the sky darkened. Sulfuric aerosols scattered sunlight, plunging the earth into eerie twilight. Temperatures dropped in sudden lurches. Winters grew longer, crops failed, and cold rains swept through dying forests. Then, just as quickly, the pendulum swung the other way. Greenhouse gases accumulated. What had been cold became unbearably warm. The planet flipped from freeze to fever in the span of millennia. Rain became acidic, scarring leaves and leaching nutrients from the soil. Oceans, already stressed, grew more acidic as they absorbed the excess carbon. Coral reefs bleached and crumbled. Plankton, tiny though they are, the base of the marine food web diminished. The chain reaction was relentless. From the smallest microbes to the largest reptiles, life found itself in an unfamiliar world. And it was during this environmental chaos, this planetary crisis, that one of Earth's great extinction events occurred. Roughly 200 million years ago, as camp continued to erupt, the Triassic period came to an end. Up to 80% of species vanished. Amphibians, reptiles, early marine creatures, whole lineages disappeared. The sudden vacancy in the ecosystem made space for new rulers to rise. And into that emptiness, the dinosaurs stepped. It's strange to think of it that way, that their age, their domination of the planet, was not just a story of survival or strength, but of timing. The lava that scorched the land and choked the skies also cleared the stage. It reset the clock. And when the smoke thinned and the temperature steadied, the world looked different. Fewer voices, fewer shapes, but new possibilities. Evolution, ever patient, began again. Today, the scars of that ancient firestorm are still visible in the cliffs of Morocco, in the rocks of Brazil, in the Appalachian foothills, in hardened basalt that holds the memory of heat. Geologists trace the flow lines, read the trapped gas bubbles, and find in them the echo of that distant violence. These rocks do not forget. They tell a story written in pressure and ash, in magma and silence. And even now, as continents continue to drift, the remnants of camp remain, not just in stone, but in the atmosphere, in the fossil record, in the DNA of species that made it through. The past does not vanish. It shapes. It leaves fingerprints on the present, even if we don't always see them. The lava that changed the sky did more than blacken the horizon. It altered the course of life itself, not in a moment, but over countless seasons. A reminder that the earth is not passive. It is alive. It remembers. And sometimes, when it moves, it does so with a force that remakes the world. If you were to stand on the rocky edge of Morocco's coastline and let your gaze stretch westward across the vast shimmer of the Atlantic, you'd be staring toward a ghost. Not a ghost in the spectral sense, but something real and ancient, something solid that once stood just across the water close enough to walk to, had you lived a few 100 million years ago. What we now know as North America once leaned against Africa like an old friend. Their boundaries weren't drawn by maps or oceans, but by pressure and stone, locked together in the grip of the supercontinent Pangea. And where New York's forests now sway in seasons of snow and sun, they once brushed shoulders with the ridges and deserts of northwestern Africa. This wasn't a casual connection. It wasn't a glance across a strait or a shared climate system. It was touch land to land, ridge to ridge, crust fused to crust. The Appalachian Mountains, so familiar and weathered now, were not alone when they formed. They rose in unison with the anti-Atlas mountains of Morocco, part of the same titanic collision, formed when ancient continents collided long before Pangea even had a name. Their bones are siblings. Their rocks match like halves of a broken plate pressed back together. Geologists were the first to see it, not in the way you'd spot a silhouette in the fog, but in the slow, careful reading of stone. They followed the lines of quartz and feldspar, matched mineral content, traced fault lines and folded layers that began on one continent and ended, astonishingly, on another. When you dig into the Hudson Highlands of New York and into the outcrops of Morocco, the rocks speak the same language. They tell the same story. Their grains are ancient fingerprints pressed into the crust, left behind when the continents began to drift apart. What we call the Atlantic Ocean is new, at least by Earth's clock. It did not exist when dinosaurs ruled, or when early reptiles crawled through fern-filled valleys. Before its waves ever crashed, before its tides began their dance with the moon, it was a rift, a wound slowly opening. North America and Africa were once part of a continuous landform, their shared edge an unbroken seam. The eastern coast of what would become the United States fit against the northwestern bulge of Africa with an almost eerie precision, like puzzle pieces separated by time. You can still feel the memory of that fit in places like the Palisades of New Jersey, those sheer basalt cliffs that tower above the Hudson River. They were formed by magma that surged upward during the birth of the Atlantic, a byproduct of the same great tear that pulled Africa and North America apart. On the other side of the ocean, in Morocco, similar formations rise, mirrors made of cooled fire, hardened over millions of years. The rocks on both shores carry identical isotopic signatures, as if they were once one body now cleaved. But the separation was not abrupt. It took tens of millions of years for the first cracks to widen, for the magma to rise, for the rift to become a sea. As the continents drifted, the young Atlantic widened slowly, fed by molten earth that pushed up from the mantle and solidified into new sea floor. The edges of the continents were stretched and thinned, their crust drawn out like taffy. Some fragments stayed behind tiny micro-continents and island arcs that now dot the ocean basin. But most of the land kept moving, carried by the silent strength of tectonic plates gliding over currents deeper than we can see. Even now, the Atlantic continues to widen. Each year, North America drifts a little farther from Africa, just a few centimeters, about the speed at which fingernails grow. It's not much in a lifetime, but across geologic time, it's an exhale that changes the shape of the planet. And yet, despite the distance, the connection remains. It remains in the rocks beneath cities, in the minerals under our feet, in the matching folds of two coastlines that no longer touch. There's something haunting about that, something intimate. To think of continents not as static bodies, but as travelers with histories of closeness, of breakups, of drifting apart. It gives the world a kind of softness, a kind of sorrow, because beneath the stories of nations and empires lies a deeper narrative, written not in words but in stone. New York and Morocco were once neighbors, not just geographically but geologically. The landscapes that now feel distant and foreign once shared the same sunrises, the same storms. They were shaped by the same ancient forces, held together by time and pressure and heat. And though they are now separated by thousands of miles of water, the memory of their connection is still there, waiting in the layers of the earth to be. Read. So the next time you walk along a coastal cliff or a mountain trail, remember this. The land you stand on has traveled. It has touched other places, leaned against other lands. And somewhere, across oceans, its twin still remembers. You don't have to be a geologist to feel it. Sometimes, all it takes is standing at the edge of a continent and watching the waves crash against the rocks. You might not know the names of the minerals beneath your feet or the precise age of the cliffs behind you, but something in the shape of the land whispers a deeper story. A story not of countries or cultures, but of ancient ruptures, long dormant collisions, and the silent echoes of a world that once was whole. the earth remembers. You can see it in the gentle arc of South America's eastern coastline, curving just so, as if still reaching for the coast of Africa. You can see it in the way the rocks of Newfoundland match those in Western Europe, not just in color or composition, but in the very structure of their folds. You can trace that memory in the mirrored mountain ranges that once ran as single ridges across continents, now separated by thousands of miles of sea. The Appalachians do not end in Georgia. They continue, in pieces, through Greenland and Scotland and into Norway, as if the land itself is telling a story of connection that outlasted the oceans. These aren't coincidences. They're scars, beautiful, stubborn reminders of Pangea's long, slow shattering. When the supercontinent fractured, it didn't break cleanly. It tore, it stretched, it cracked. And in doing so, it left behind a map etched into the rocks themselves, waiting to be read by anyone curious enough to look closely. Fault lines that began in one continent find their counterparts in another. Rift valleys that opened as Pangea pulled apart can still be seen today, not as active tiers, but as settled basins, places where sediment gathered in the emptiness left behind. Mountain roots that once shared the same subterranean pressure now lie divided, like ancient siblings growing apart with age, yet still sharing the same deep origin. Even the deserts bear witness. The sand dunes of the Sahara have mineral twins in parts of South America, their grains born from the same ancestral rock. Wind-blown particles traveled and settled across lands that once shared the same crust. The red soils of Australia and India hint at a time when both were joined within Gondwana, long before they drifted to opposite corners of the globe. The fingerprints of unity are everywhere, if you know where to look. Some of the evidence is subtle. It lives in the fossil record, identical species found on continents now separated by oceans, a fern here, a reptile there. They didn't swim across the seas. They walked on land that was once unbroken, their bones now resting in different countries, different museums, but part of the same chapter in Earth's biography. Other clues are massive, undeniable. Large, igneous provinces, those vast stretches of cooled lava from ancient eruptions, span continents as if someone once painted with fire across a single canvas, and the pieces were later torn apart. What begins in Brazil finds its echo in West Africa. What starts in Antarctica reverberates in India. The symmetry is not imagined. It's baked into the crust. Even the movements of the continents today are guided by those ancient break lines. The mid-Atlantic ridge, where new seafloor is born, follows the scar left by Pangea's parting. The continents drift outward, slow but steady, as if still remembering which way to go. It's not just momentum, it's inheritance. The land doesn't forget its past, it moves with it. And perhaps the most haunting truth is this: Pangea was not the first supercontinent, and it won't be the last. Before it, there was Rodinia. Before Rodinia, there were others. The earth gathers and scatters its lands in cycles that span hundreds of fand, millions of years, folding and unfolding like lungs drawing breath. We happen to live in a time between gatherings, a time of scattered continents and wide oceans. But the plates are still shifting. They are always shifting. Slowly, silently, beneath cities and seas, they are moving toward each other once more. One day, far beyond our lifetime, a new supercontinent will rise. The shapes will be different, the collisions unpredictable, but the process will be the same. Mountains will rise where there are none now. Oceans will vanish. And the echoes of Pangea will blend with the new scars being formed, layering one memory atop another. When you look out at the land, at the strange symmetry between places, at coastlines that seem to belong together, at rocks that whisper of distant homes, you are witnessing the persistence of memory written in stone. You are standing on a piece of something that once belonged to something larger, and if you listen, not with your ears but with your imagination, you might hear the quiet hum of that ancient connection still there, just beneath the surface. The continents have never been still. Even when they appear unmoving beneath our feet, solid, reliable, eternal, they are in motion, carried along by forces older than the air itself. The world drifts, quietly, relentlessly, as if the planet were dreaming and slowly turning over in its sleep. And with every shift, every inch of movement, life changes with it. Oceans reorganize. Winds alter their courses. Species vanish and new ones rise. What seems like slow, geological inevitability is, in truth, a restless story, a story of constant rearrangement, of cause and consequence written across deep time. When Pangea began to break apart, the world entered a new rhythm. The supercontinent had once gathered heat in its vast interior, making its heart arid and unpredictable. But when it fractured, it released the pressure, and air and water began to move differently. New shorelines appeared, vast inland seas drained away, and ocean currents found new paths to follow. What had once been a single, immense landmass became a collection of islands on a planetary scale, continents adrift in slow procession. These drifting worlds reshaped everything: the temperature of the air, the chemistry of the seas, the patterns of life itself. As continents moved, they carried their climates with them, dragging deserts and forests across latitudes like travelers bearing old memories. When a continent drifted closer to the poles, ice began to grow at its edges. When it neared the equator, jungles and savannas bloomed. The Earth's face became a living mosaic of shifting environments. Creatures adapted, followed, or perished. Entire ecosystems migrated over millions of years. Trees and rivers slowly replaced by grasslands, coral reefs by frozen shelves, until the world that emerged bore little resemblance to the one before it. The oceans changed first. They always do. When continents moved apart, new ocean basins opened between them, and as they closed elsewhere, others disappeared entirely. Currents began to twist through these new corridors of salt water, redistributing heat across the planet. Some currents, like vast arteries, carried warmth toward colder regions, softening winters and feeding the rain. Others plunged into the deep, pulling oxygen and nutrients into the abyss. The global climate became a moving system of exchange, its patterns defined by the shapes of the continents that drifted above it. When the Atlantic opened, it changed everything. The new ocean became a conveyor of warmth, its currents flowing northward, altering weather across the world. And later, when India broke away from Africa and began its long, lonely sprint toward Asia, it brought with it a new upheaval. The collision that birthed the Himalayas not only carved mountains into the sky but reshaped atmospheric circulation itself. Monsoons began to pulse across southern Asia, rhythms of rain and drought that still define human life today. What began as the slow crawl of crustal plates became the heartbeat of climates and civilizations. Every movement carried consequences invisible at first but profound in time. When Antarctica finally reached the South Pole and became cloaked in ice, global sea levels dropped, temperatures fell, and life had to adjust again. The cold transformed ocean currents, isolating ecosystems, creating new evolutionary paths. Penguins appeared where once there had been forests. Whales grew larger to follow the great currents that formed in the chill. The world turned, and life followed. And yet, for all this upheaval, there was a strange kind of balance. Each drift, each rift, each mountain rising or ocean deepening, created new opportunities as old ones vanished. Species that could not endure gave way to those that could. Warm-blooded creatures evolved in the wake of cooler climates. Grasses spread where forests thinned, giving birth to herds that shaped the plains and predators that chased them. Even our distant ancestors owe their existence to these slow rearrangements. The African Rift Valley, where early humans first walked upright, is itself the scar of a continent in motion. We are, in the most literal sense, children of shifting ground. It's easy to imagine the continents as ancient and wise, drifting slowly but with purpose, as if they know where they're going. But there is no destination, only movement. The plates continue to glide, a few centimeters each year, guided by the deep convective currents of the mantle below. In another 100 million years, the map will look entirely different again. The Pacific will shrink, new mountains will rise, and perhaps the continents will gather once more into another supercontinent, a future Pangea, a reunion written into the planet's long pulse. If you could step outside of time and watch it all unfold, the gathering, the drifting, the collisions, the floods and droughts, you would see a kind of breathing, a pattern of expansion and contraction, of creation and renewal. The continents are not just land, they are instruments of the Earth's rhythm, and everything that crawls or flies or swims has learned to move in time with that rhythm, even if it doesn't know it. Life endures because the Earth never stops moving. Its restlessness is our inheritance. We live in the wake of continents, in the currents they shaped, in the climates they left behind. Every gust of wind, every tide, every rainfall, every mountain that looms in the distance, they all trace back to that slow, patient drift. The world we know is only a snapshot of that motion, a fleeting arrangement of pieces that have been colliding and separating since before there was life to see it. The continents will continue to wander long after we're gone. They will carry the memory of our time, fossils of our bones, traces of our cities folded into their future mountains and ocean floors. And the planet will keep on breathing, reshaping itself again and again, reminding whatever life remains that nothing here is permanent, but everything is connected. Before Pangea, the Earth had already gathered and broken itself many times. The supercontinent that feels so ancient to us was, in truth, only one verse in a much longer song. Beneath our oceans and mountains lies the memory of others, worlds that rose, drifted, collided, and were forgotten. They had names, given long after their dust turned to stone. Rodinia, Columbia, Nuna, each one a different version of the same dream, the planet's ceaseless instinct to come together and fall apart again. The Earth is old enough to have done this many times, and it will do it again. The continents are not fixed. They are wanderers, always drawn together by gravity and heat, only to be torn apart by the same forces that made them. Deep beneath the crust, the mantle moves in slow, churning currents. Those hidden rivers of molten rock carry the continents like rafts on a restless sea. Over hundreds of millions of years, they drift toward one another, collide, merge, and rise into mountain ranges so vast they reshape the air itself. Then, as the heat builds beneath them, cracks open, magma spills forth, and the continents drift away once more. The Earth breathes in this way slowly, rhythmically, an inhale of unity, an exhale of separation. Long before Pangea's forests and deserts, before the first dinosaurs walked across its plains, there was Rodinia. Around 1 billion years ago, the world gathered itself into a single, colossal landmass. Rodinia was not lush like Pangea. It was stark, barren, mostly silent. The atmosphere was thin, and the seas were still finding their rhythm. Yet even then, life clung to existence, tiny, simple, and patient. Microbial mats grew along ancient shorelines, and the oceans teemed with the earliest stirrings of complexity. Rodinia's mountains rose high and sharp, born from the slow collisions of earlier continents whose names are lost to time. Winds howled over deserts of iron and stone. Ice advanced and retreated in great waves. The earth was colder then, perhaps lonelier, its face still rough from creation. Eventually, Rodinia fractured. The process took tens of millions of years, as all continental partings do. The planet warmed and stretched, and cracks formed deep within the crust. Magma rose, splitting the supercontinent apart, and the first new ocean spread between its fragments. Out of that slow destruction came change. The continents drifted into new positions, climates shifted, and the planet began to transform. Some scientists believe the breakup of Rodinia helped trigger one of the greatest ice ages in Earth's history, snowball Earth when the entire planet may have been locked beneath frozen seas. But even then, beneath the ice, life endured, waiting. Before Rodinia, there had been others. Columbia, sometimes called Nuna, was one of the earliest supercontinents we can still trace in the rocks. It existed nearly 2 billion years ago, when the planet was still young, its crust thin and restless. The air would have been harsh, the days shorter, the sun dimmer. Yet even then, the slow drift of landmasses followed the same pattern that governs the Earth today. Subduction zones, mid-ocean ridges, and the constant churn of heat from below all played their part. The continents collided and merged into one, forging mountains that long ago eroded into dust. When Columbia finally broke apart, it set in motion the cycles that would continue through Rodinia, Pannotia, Pangea, and beyond. Each time the continents reunite, the world changes profoundly. Oceans vanish, climates shift, ecosystems collapse, and new ones rise. These transformations are not random. They are part of a deep planetary rhythm, one that unfolds so slowly that no single species can witness its full arc. Humans have only seen a moment, a flash in this long story. The mountains we think eternal are merely the newest wrinkles on an ever-changing skin. And one day, it will happen again. The continents, still drifting, will meet once more. The Atlantic Ocean will close as North America moves back toward Africa. Australia will creep north until it collides with Asia. The Pacific, vast and ancient, will shrink and vanish. New mountains will rise where oceans once lay. Scientists call this future world Pangea Proxima or Amasia, depending on which path the continents take, but the name matters less than the truth behind it. The Earth will gather itself again. When that time comes hundreds of millions of years from now, our world will look alien. The sky may be different, the air warmer or colder, the creatures unrecognizable. The planet will not remember us in any conscious way, but our fossils will be there, pressed into its layers, fragments of an age that once was. The cycle will continue, unbothered by memory or meaning. It's strange to think that the continents we stand upon, the ones we think of as permanent, are only passing through their current arrangement. The edges of Africa, the coast of California, the mountains of Asia, all of it will move, all of it will change. The map we know is a snapshot, not a truth. Beneath it, the Earth continues its patient, rhythmic pulse, gathering and scattering itself across deep time. And so the story of the supercontinents is not just one of geology. It's a story of recurrence, of endings that are beginnings, of destruction that becomes creation. The land we walk on has been many lands before, and will be many again. It carries the memory of its previous selves in the quiet language of its rocks. If you press your palm against the ground and imagine far enough back, you might feel it, the faint pulse of a planet that has been breaking and mending itself for billions of years. If you could stretch time out far enough beyond the rise of cities, beyond the first forests, beyond even the invention of bones, you would see that the Earth moves with a rhythm. Not the steady tick of seconds or the slow turn of seasons, but something deeper, older, more patient. A pulse that beats across billions of years. It is the supercontinent cycle, the endless gathering and scattering of land, the slow inhale and exhale of a living planet. Every mountain range, every ocean, every coastline, we know is part of this rhythm. Each one temporary. Each one caught between the slow, inevitable motions of reunion and separation. The Earth's crust is not one solid shell, but a mosaic, a collection of drifting fragments called tectonic plates. They glide on the mantle, the viscous layer beneath, pushed and pulled by currents of heat rising from the planet's core. These plates collide and merge, split and drift apart. It happens too slowly for us to see, yet over millions of years the purporters act of the Panner effect is monumental. Continents converge, forming vast supercontinents that dominate the globe. Then, As heat builds beneath them, they split apart again, sending their fragments drifting into new configurations. It's a pattern as certain as the tides, only slower, grander, quieter. Each time the Earth pulls its continents together, something profound happens. Mountains rise where plates collide, forcing rock deep into the atmosphere and drawing carbon from the air. Weather patterns shift. Ocean currents are rerouted. The balance of heat and cold across the planet changes. Life must adapt or vanish. Each assembly of a supercontinent marks both an ending and a beginning, an era closing, a new one taking shape, and each breakup brings renewal. As continents drift apart, new seas open, new coastlines emerge, and isolation breeds diversity. Life evolves differently in each separated world, branching into forms that could never have existed in a single, unified landmass. Rodinia, Columbia, Nuna, Pangea. These are only the names we give to the visible peaks of this repeating cycle, the ones our science can still trace. There were others before them, now erased by time. Each followed the same pattern: collision, unification, fracture, drift. Each one left its mark in the scars of the crust, the suture zones where ancient mountains once rose, the deep rifts where the land later tore itself apart. These are the fingerprints of the Earth's long, slow heartbeat. When Pangea broke apart around 200 million years ago, the world entered its most recent cycle of expansion. Oceans widened, new shorelines appeared, and continents began their slow drift toward the shapes we recognize today. The Atlantic was born, stretching year by year as magma welled up from below. The Pacific began to shrink, its vast basin closing along deep trenches. We are living in the outward breath of the cycle, in the time of scattering, but even now, the seeds of the next gathering are already planted. Beneath our oceans, in places like the Pacific Ring of Fire, subduction zones are swallowing seafloor, drawing continents imperceptibly closer. One day, long after our species is gone, the next supercontinent will rise a new configuration of the same ancient pieces. Some scientists call it Pangea Proxima, others Amasia or Nova Pangea. Its future shape depends on which plates move fastest, which oceans close first. Perhaps it will form around the equator, ringed by a single world sea. Or perhaps it will gather near the North Pole, a cold, desolate giant under long shadows. Whatever its form, it will not be the last. The Earth will continue this cycle as long as it breathes heat from its core, as long as its crust remains alive and restless. There's a strange comfort in that thought that the continents will keep meeting and parting long after we're gone, that the story of the Earth is one of endless renewal. We tend to think of mountains as permanent, oceans as eternal, but they are as fleeting as we are, only slower. The Himalayas will wear down, the Atlantic will vanish. Even the Pacific, vast and ageless in our imagination, will one day close, and when it does, the land will rise again, folding into a new world. It's easy to miss the motion of something so slow, but the evidence is everywhere, written into the planet itself. The matching coastlines of distant continents, the identical rock layers found on opposite sides of oceans, the remnants of mountain belts that once spanned worlds. If you look closely enough, the illusion of stillness dissolves. The ground beneath you is not fixed. It's drifting, rising, and reshaping itself even now. You are standing on something ancient that has already been 1,000 places. The supercontinent cycle is the closest thing the Earth has to memory. Each collision writes a chapter, each breakup erases and begins another. The mountains and oceans we know are only the latest words in that story. And when they're gone, when this map we call familiar is unmade, the cycle will continue, steady and unhurried, pulsing beneath the silence of time. The Earth does not forget how to come together. It only waits until the moment is right to begin again. Pangea never truly vanished. It broke, it drifted, it reformed itself into the continents we know, but its bones and breath are still here, buried beneath cities, echoing through fault lines, resting in the quiet memory of the Earth. You can see it in the shape of coastlines, the fit of continents that once leaned together like puzzle pieces waiting to be joined. You can feel it in the tremor of earthquakes, those sudden reminders that the ground beneath us is not still, that the world is still rearranging itself, still chasing the memory of its earlier wholeness. And sometimes, you can even hear it in the stories we tell about a lost world, a time when everything was one. Beneath the surface of every continent lies evidence of that ancient unity. Fossils of identical creatures rest in stone thousands of miles apart, their bones perfectly matched across oceans. In South America and Africa, scientists have found the same extinct species of freshwater reptile, Mesosaurus, imprinted in rock as if it had simply walked from one continent to the other. Glossopteris, a fern that once carpeted Pangea's interior, left its leaf impressions on rocks now scattered across India, Antarctica, and Australia. These fossils are like messages written in stone, proof that what is divided now was once seamless, alive, and whole. Even the rocks themselves tell the story. The mountain ranges of North America and Europe still line up, grain for grain, fold for fold, remnants of a single chain that split in two when the Atlantic Ocean opened. Earthquakes, too, are echoes of Pangea's afterlife. They often trace the ancient scars where the supercontinent broke apart. The rifts that once tore Pangea open didn't vanish. They hardened into fault lines, sleeping most of the time, but still capable of stirring. Every tremor, every slip beneath our feet, is a small continuation of the same tectonic movements that first divided the world. The planet remembers where it was once broken, and sometimes, when the pressure builds, it reminds us. In those moments, you can almost feel the living pulse of deep time, a heartbeat that's never really stopped. Even in the ocean floors, the memory remains. Along the mid-Atlantic ridge, new crust is still forming, pushing the continents farther apart, continuing the same drift that began when Pangea fractured. The seafloor spreads outward in a slow, silent exhalation, carrying bits of the past with it. If you could trace the magnetic patterns in that rock, they'd tell you the story of continents moving like clouds, parting and rejoining over millions of years. Pangea's legacy isn't fossilized, it's in motion. It's alive in every tremor, every tide, every shifting grain of sand along the edge of a continent that used to be something else. But perhaps the strangest part of Pangea's survival is how it lingers in the human imagination. Long before geologists gave it a name, many cultures carried fragments of its memory in myth. Stories of a single vast land that split apart, scattering people and creatures across the world. The ancient Greeks spoke of a time when the gods tore the continents apart to separate humanity. Indigenous stories from Africa and Oceania describe lands that drifted or sank beneath the sea. Even the tale of Atlantis, the lost continent swallowed by the ocean, echoes faintly with the truth of a planet that once gathered itself into one body, only to fracture again. These myths aren't science, but they hold a kind of emotional truth. The intuition that the earth was once united, and that unity was lost. There is something deeply human about that sense of separation. We have always tried to imagine what it means to belong to a world that is constantly in motion, a world that once fit together and then fell apart. Pangea's story mirrors our own in quiet ways, how families scatter, how cultures drift, how the pieces of our shared history still line up if you look closely enough. The continents are not the only things that have fractured and carried memory with them. We have too. Scientists can measure the legacy of Pangea in numbers, millimeters of drift each year, isotope ratios in ancient rocks, the alignment of fossils across hemispheres. But its truest presence is something more subtle. It's in the idea that the planet is a living system, that its history is not a collection of separate eras, but a single, ongoing story. Every earthquake, every mountain, every fossilized fern is a footnote in the same narrative of movement and renewal. When you stand on a mountain ridge in North America and see a similar horizon rising across the sea in Europe, you're looking at two halves of the same sentence written long ago. When you feel the ground tremble, you're hearing the earth continue a conversation it began hundreds of millions of years before us. And when you listen to the myths of lost continents, of lands divided by time and tide, you're listening to echoes of Pangea, the memory of a connected world that still lives beneath our own. The earth, it seems, never forgets what it once was. It carries its past like a rhythm beneath the crust, steady and slow, an ancient heartbeat stretched across eons. And though the continents drift farther apart each year, their shapes still remember how they fit together, just as we sometimes remember the wholeness of things we can no longer touch. Pangea lives on not as a place, but as a pulse, a quiet, endless reminder that everything once was one. Long before anyone knew the word Pangea, people were already dreaming of it. They didn't know about drifting continents or tectonic plates, or that the land beneath their feet was moving at all. But somehow, they sensed it, a memory older than memory itself. Across cultures and centuries, stories emerged about a single world that had been torn apart. Lands swallowed by the sea, continents that drifted away, civilizations lost to time. The idea of a world that was once whole, then broken, lives deep in us. Maybe because, on some level, it's true. The myth of the lost world is one of humanity's oldest recurring dreams. You can hear it in whispers from every corner of the planet, passed down in songs, in carvings, in stories told by firelight. The Greeks imagined Atlantis, a shining island civilization that fell beneath the waves in a single night. In Polynesian lore, there were great islands that once connected all peoples before the sea rose to separate them. The ancient Hindus spoke of a sacred continent called Kumari Kandam, now lost beneath the Indian Ocean. Even the Maya had stories of drowned lands and vanished kingdoms. These tales, born on different continents, spoke the same language of loss and longing. They all seemed to carry the same rhythm, the idea that the earth was once united, that we were once closer to one another, that something vast and beautiful slipped away. And when modern science finally gave that intuition a name, it felt less like discovery and more like remembering. Pangea, a word that means all earth, a world where all continents were one, touching and breathing as a single body. Suddenly, the myths felt like echoes of something real, fossilized in culture the way leaves are pressed into stone. When people first began to map the planet, they noticed something strange. The edges of the continents looked like they might fit together. Africa and South America, in particular, seemed almost designed to match. It was an observation so simple that even early explorers noticed it, sketching coastlines that mirrored each other across vast oceans. But for centuries, the idea that continents could move seemed impossible. The earth, people thought, was fixed, solid, eternal. It took generations before someone had the audacity to suggest otherwise, that maybe the myths were right, just not in the way anyone had imagined. Alfred Wegener, a German scientist in the early 20th century, was one of the first to give voice to this idea. He looked at the jigsaw fit of continents, at the identical fossils found on opposite sides of the Atlantic, and saw not coincidence, but memory. He proposed that the land had once been joined as one great supercontinent before slowly drifting apart. The scientific world laughed at him then, dismissing his theory as fantasy. But the earth is patient, and truth has a way of waiting. Decades later, with the discovery of seafloor spreading and plate tectonics, Wegener was proven right. The continents do move. The earth does change its face. And what we once thought myth turned out to be history. Maybe that's why Pangea feels familiar even though no human ever saw it. Because the story of its breaking mirrors something deeply human. The longing for connection, the loss of unity, the belief that once, long ago, we were part of something larger, something whole. In that way, the legend of Atlantis isn't about a city at all. It's about a feeling, a quiet grief for what has drifted away. The oceans became metaphors, the distances between lands standing in for the distances between people. Every story of a sunken world carries a little of that ache, that maybe we lost more than land. Even now, Pangea lingers in art and imagination, in novels, films, and dreams of utopias lost beneath the waves. It appears in maps of what was and what might be, reminders that the world is fluid, not fixed. Some even say we feel its ghost when we look out at the horizon, the faint intuition that what lies across the sea is not foreign, but once familiar. There is comfort in that thought, a strange kind of homecoming hidden in the idea that the world has been one before and might be again. The myth of the lost world is not just nostalgia for a geological past. It's a reflection of our own restless nature. We build and rebuild, connect and divide, gather and scatter. We lose and we remember. The Earth's story is our story, told in stone and tied in silence. The same forces that pulled continents apart still shape us in subtler ways. Cultural drift, migrations, exiles, the endless search for belonging. Perhaps we keep inventing stories of vanished lands because we need to believe that what's broken can be made whole again. Pangea may have vanished beneath millions of years of movement, but the idea of it endures in myths, in rocks, in our imagination. It is both real and symbolic, a world that once existed and a longing that never left. The lost world was never truly lost. It lives in us, in the pull toward connection, in the quiet memory that the earth and all who walk it were once united under the same sky. Far beneath our feet, the earth is already preparing its next act. The continents we know separate, scattered and familiar, are drifting, inch by inch, toward a future no one will see. It's happening in silence, at the speed of fingernails growing, guided by forces as old as the planet itself. But in the patience of deep time, that is enough. Give it 250 million years, and the world will draw itself together again. Oceans will close, mountains will rise, and a new supercontinent will form. Scientists call it Pangea Proxima, the next Pangea. It will not be the same as the last. Nothing ever is. The shapes of the continents will be different, the climate unrecognizable, the sky perhaps tinted by a sun slightly brighter than our own. But the rhythm is familiar. This gathering and scattering, this slow breathing of the planet has happened many times before. Rodinia, Columbia, Panodia, Pangea, and now another will come. The earth folds itself, then unfolds, in endless repetition. It is a cycle that doesn't need witnesses to continue. The future supercontinent will take form as the Atlantic Ocean closes. For now, that ocean still widens each year, pulled open by the mid-Atlantic ridge, where molten rock rises and hardens into new seafloor. But the ridge will eventually falter. The spreading will slow, then stop, and new subduction zones will form along the edges of continents. The ocean that once split worlds apart will begin to vanish, swallowed back into the mantle from which it came. North America will creep eastward, its bones folding toward Europe and Africa once more. South America will follow, its western edge grinding against the Pacific until that vast ocean too begins to shrink. The world, always in motion, will find its way back to itself. Imagine it, 250 million years from now, the map we know erased, replaced by a single immense landmass surrounded by a global ocean. The outlines of today's countries gone, their coastlines fused into a new shape, something strange and beautiful and alien. The Himalayas, worn down by time, will give way to a new ring of mountains formed where continents collide. Perhaps North America will press against the Sahara. Perhaps the Mediterranean will vanish entirely, crushed under the weight of the new assembly. Scientists draw different models, some calling the future world Amasia, others Nova Pangea, but they agree on one thing: the Earth will not stay scattered forever. it always gathers again. The new Pangea will bring with it a new climate, born of its size and shape. Supercontinents breathe differently than the fractured world we inhabit now. With less coastline to regulate temperatures, the interior will bake under endless heat, while the edges drown in storms. Deserts will stretch for thousands of miles. Rain will fall only at the edges, where the ocean's breath can still reach. Winds will circle the land in strange new patterns, carving dunes and shaping rivers in ways no human mind could predict. The animals that exist then, if any still do, will adapt or vanish. Evolution will not stop, but it will move to a new rhythm, shaped by a world that has reassembled itself from the memory of its past. Some scientists believe that the formation of the next supercontinent will cool the Earth, as the recycling of crust and the rearrangement of land alters the flow of carbon through the air and sea. Others think the opposite, that the closed ocean will trap heat, and volcanic activity will flood the sky with greenhouse gases. Either way, the planet will find a new balance, just as it always has. What feels catastrophic to life is merely change to the Earth. The thought of it, this future world forming in silence, carries a strange comfort. It reminds us that nothing here is permanent, not even the continents we stand on. What we think of as stable ground is only a moment in motion. Our cities, our mountains, our maps, all of it will be folded into something else, some future layer of stone. The fossils of our bones, our monuments, our machines, may one day rest deep beneath the soil of Pangea Proxima, waiting for whatever species walks that land to discover them and wonder who we were. If any consciousness remains then, if any eyes look out across that new world, they will see different constellations overhead. The stars will have drifted too, slow companions to a planet always rearranging itself. But even then, even under a different sky, the pattern will be the same. The continents will gather, they will break, they will drift. Oceans will open and close, mountains will rise and crumble. The Earth will continue its long, slow exhalation, and maybe, in that far future, something will feel the same quiet intuition we do now, that the world has been one before. That somewhere in its deep memory, the Earth remembers every time it has come together, every time it has fallen apart. Pangea Proxima will not just be a new world. It will be a continuation, the next verse in a song the planet has been singing for billions of years. Every breath you take, every grain of dust on your skin, every atom in your bones has been part of something older than imagination. The calcium in your teeth once drifted through ancient seas. The iron in your blood was forged in dying stars before the Earth even existed. The oxygen you breathe has circled through forests that grew and vanished hundreds of millions of years ago. We are not separate from the Earth, we are its continuation. The continents move beneath us, and we move with them, built from their fragments, carrying their memory in our chemistry. If you could look deep enough, past layers of time and rock, you would see that the story of Pangea is not only about land, it is about everything: life, change, endurance, and return. The same forces that drew the continents together and tore them apart also shape the patterns of our existence. We are made of motion. Even standing still, we drift, atoms shifting, continents beneath our feet, gliding silently over molten currents. The illusion of stillness is a kindness the Earth gives us. Underneath, everything is alive. The carbon in our cells has passed through volcanoes and coral reefs, through ferns that once grew on Pangea's plains. The hydrogen in our water fell as rain on deserts that no longer exist. The silica in the glass around us was once sand on an ancient shore. We carry the fingerprints of places long gone, of mountains turned to dust, of rivers that flowed across the supercontinent's skin. In the deepest sense, we are fossils animated by time, built from the ruins of worlds that came before. Sometimes we think of Pangea as something distant, a myth written in stone, a chapter closed. But it is not gone. It's in the shape of the land, in the mirrored coastlines that still yearn toward one another, in the shared roots of mountains and minerals. It's in the life that adapted, endured, and evolved as the continents drifted apart, even in us. We are the children of that scattering. Every species alive today is descended from survivors of that ancient fracture. The separation of land shaped evolution's path, carving diversity into being, creating the world's many forms of life. The breaking made the beauty, the distance made the difference, and yet, in that separation, a hidden connection endured. The earth never truly divides, it only rearranges itself. Every piece remains part of the whole, still joined beneath the crust by currents of molten rock, by gravity, by memory. The same is true of us. We are individuals, yes, but never isolated. The molecules that make us pass through others, through air, through oceans, through time. You are breathing atoms once breathed by ancient trees, by trilobites, by other humans long returned to dust. What leaves us never truly leaves. It only finds new forms. It's strange to think that the world beneath your feet has traveled farther than you ever will. The rock below you once lay under a different sky, part of a different continent. The soil that grows your food may once have been seafloor, pressed beneath the weight of an ancient ocean. The mountain you see in the distance might have been the root of another, older one, worn down and rebuilt over eons. Everything we stand on has been somewhere else. The earth remembers in layers, and we are walking on its memory. When Pangea formed, it was not the beginning, and when it broke, it was not the end. It was one heartbeat in a rhythm that continues. The continents will gather again, though we will be long gone. A new world will rise where this one once stood, and life, whatever form it takes, will build itself from the dust of ours. And perhaps, far in that future, something will look up at the stars and wonder what came before, the way we do now. There is comfort in knowing that we are part of this cycle, that nothing is wasted, that even loss becomes foundation. The earth does not cling to permanence. It transforms, it breaks and reforms, again and again, shaping beauty from its own impermanence. And maybe that's the quiet truth at the heart of it all, that the world, like us, finds meaning not in what endures, but in what continues. You are not standing on the earth. You are part of it. The minerals in your body are pieces of its crust. The water in your veins has flowed through ancient rivers. The air in your lungs once brushed the surface of Pangea's seas. You are the planet, remembering itself. And though continents drift, and mountains fall, and oceans rise to swallow the coasts, something within us stays connected to the same deep pulse. The story of Pangea is the story of us. We are made of ancient earth, fractured, reformed, and still beautifully whole.